Okay, so identify the variables and tell whether each one is categorical or quantitative. So what are my variables? Dog breed and gender. What type of variables are those? Categorical, because the only way you're going to see a contingency table is if it is, in fact, categorical. All right. Which of the W's are unknown? When? Definitely. You could argue where. Why could you argue where? Exactly. Local to who? I have no idea what you're talking about on that one. So you need to be a little bit more clear as to what you don't, but somebody else would have to. Okay. The last one is just kind of weird. Most of you probably assume, how did I get the data? Do you understand how we don't really know? I don't know if that's a random sample. I don't know if that's everybody at the dog show. I don't know how many dogs are at a dog show. Or that's not even how many dogs. It's just what people like. I don't think... if you can... probably won't be a deal breaker piece. I'm trying to think about, like, if it was a 10-point problem, maybe 1 point, if you don't specify how it was collected. But run through the W's and ask yourself, could you answer each of those? And does it specifically state how the data was collected? It just says that they asked people. So I can kind of, you might say that how did they collect it? They collected it by asking people. So I can kind of go either way with that. Sure. You're more than welcome to. Okay. Parentheses. All right. Keep on with that guy. What percent of the responses were from males who favorite Labradors? Now, this specifically says percent. What do you get? 6.58%. Okay. What percent of male responses favor Labradors? 14.91%. And what percent of the people who chose Labradors were male? And for something like that, the work that you're expected to show here is you have to show what your ratio was. Please don't simplify the ratio, please, or your fraction. Please don't do anything to it. Just say total out of. Okay? That is considered your work for one of these problems. Yes, ma'am? We're always going to kind of think about rounding decimals to 4 decimal places. But to turn a probability into a percent, you multiply by 100, so the decimal rounds to 2. Okay? Does that make sense? If 100th if you're doing percent, 4 decimals if you're doing probability, which would be the before you multiply by 100 point. So like it would have been 0.0658. 0.0658, yes. Okay. Good? Chilling? Awesome. So marginal distribution of breeds. When I'm talking about marginal distribution, do they specify relative? No. I mean, if you want to give relative here, you can. But really, this is just the most annoying question because it's just saying, hey, what are the totals for your breeds? So you say it. Words suck sometimes. Odds are, if I were to ask you a question like this on a test or a quiz, I wouldn't give you a bajillion options to list out. Yes, sir. No, because the marginal distribution is, well, I guess that's kind of going the way of percentages. So if you want to turn that into a ratio, I guess that's okay. Mm-hmm. If it doesn't say anything about relative frequency, then just give me counts. It's just the easiest thing. Okay? Write a sentence or two about conditional relative frequency. So for this one, you have to do percents. Distribution of the dog breeds among female respondents. So what's number is going to go in my denominator for all of those? 348. I can't see what it was anymore. So all you're going to do is run them through. Boom, 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 boom. Okay, so among female respondents, that means that is my group that I'm narrowing my focus to, just the females. And then I turn each of the females' totals into percents. Because again, fun. Yes. Exactly. I like to think about it as narrowing in your view, like closing a window a little bit. And crop it out so all I see is that one variable. Not really even that one variable, but that one condition. That one characteristic of that variable. Okay? No, it's just basically understanding what the difference between a column and a row is. And the only way that I know the difference is I know that in Greece, columns go like this. Other than that, simply because it's your choice as to which variable you put on the rows and columns. Okay? So they're just trying to be specific so that you have one answer and not a bajillion answers. Okay? All right, so what do you think? Is the breed selection independent of gender? Yes or no? 50-50 shot there. Yes, they are independent. No, they are not independent. No. And if I'm trying to say no, they are not independent, or no, we believe there is an association, that's the nice one. That's the one where you have to give me just one probability that is clearly not the same. That's all you need to do here. So this one, we've got a couple. What we're talking about here is they're saying 56% of the responders were females, but for the golden retrievers, 64% were females for the golden retrievers, 62% for the Dalmatians, 47% for the Labradors. Basically, I would have said, let me draw this real quick. I would have said, whatever 348 over 623 is, that's my probability of a female. So that is 56% about. And then I would say, but, and I would look for what do I think is going to be the most glaringly opposite thing. And yeah, I would probably do the golden retriever. So I would say of the golden retrievers, 64%. So 64% is not 56%. You can either compare a subgroup to a subgroup or a subgroup to a total. So let me spin back at the table real quick and I'll show you what I mean. You can do this proportion, 348 over 623, to any of these other proportions. Or you could compare any of those two proportions and ignore the total. Is that clear? You could have also done it the other way around. You could have said this over this, compare it to this over this, or this over this. As long as you find one that is clearly not the same, you're good to go. Again, I would never give you a problem like this where there are seven choices, and then say, hey, show me that they are independent. Because that's just annoying. That means you've got to give me 7 different proportions that are equal. Which really sucks. Yes, ma'am? Yes. And you've got to be careful because sometimes you will find the first probability you grab is within 2%. But all of them are not. Okay, so as long as you have one that's not within 2%, and 2% is kind of like my arbitrary decision-making point for you guys right now. That's close enough. When we get much later on in the school year, we're going to do something called a chi-squared test. And we're going to get a very specific value where we're going to say, okay, looking at everything. Is it crossing the line of that or not? Okay? Yes, ma'am. If you're going this way, so 58 over 348, you would then have to do 33 over 275. Or 91 over 623. Oh, okay. Hi. extreme close-up. So whatever that pattern is that you start on the first proportion, keep going that same way for everything else. I wouldn't give it to you. Yeah, I wouldn't. Like normally, I'll give you something that has like 3 by 2 or 3 by 3 maybe in the worst case. Okay, because that's just mean. There's no point in that other than just to be mean. I mean, I can be mean. That's definitely a true statement, right? Yeah! Okay, so we did that one. We did this one. So now we're on to the other example. So you can see here, very, very similar. Hey, geez, I wonder what the quiz is going to look like. You're going to start noticing that the quizzes and the warm-ups remarkably similar, at least for the free response portions. Okay, so variables. What are my variables? Mode of transportation. I love the fact that you said the word mode. And gender. And those are categorical. So which of my W's do I not know? When, where, and how. Because, yeah, I mean, you could say they were asked, but it's not very clear. Bless you. So, yep, I would definitely say when and where, big ones. How is one that I could kind of go either way. So running through the percentages for number 9. Again, while those are the percentages, you have to show your ratios. That is not optional. There's very little work that goes with those, but the fraction themselves is considered to be the work. Okay? Marginal distribution of gender. This is more like what I would expect you to write out. 2 things. Yay! So I would say there are 86 males and 102 females. And unless they say relative frequency, just do counts. Life is so much simpler that way. You don't want to add an extra layer of work onto your problem because that's an extra opportunity for you to make a mistake. You'll hear me talk a lot about in this class, maximizing your scores. And sometimes maximizing your scores means stop while you're ahead. Okay? So write a sentence or two about the conditional relative frequency. So first off, answers have to be in percents. And it says mode of transportations for the boys. So I'm only looking at the males. So that means that I would say, and you don't need to write comparing here. It says more boys caught rides to school. You do need to have those percentages in there. So I would say 43% of boys used any other mean of transportation, 35% rode the bus, and 22% used personal transportation. Okay. So what do you think? Is transportation independent of gender? Yes, and this is where you would have to list out all of those percentages. They go a lot more in depth, but they say 34% of the students ride the bus. So that's close to either the 35 or the 33 for boys and girls. 44% caught rides, and 22% used personal, which matches the boys and the girls. You really don't need to list all of those. Basically, if I go back and I look at a table, I pick one direction. Get it? Not the other direction. I pick one direction. Do you want to look at rows or columns? Columns. So how many columns are there? 3. Knock one off. So you don't want to do total? So that's all you got to do. I usually pick whichever direction has the fewest number of options. And whatever rows or columns that you choose, knock off one, because if 2 match, the third has to match. Does that make sense? Because they all go hand in hand. So you can look at male bus to total bus, female to total, da-da-da-da-da-da-da. As long as you show that those proportions are within 2, you're good to go. Okay? You don't have to. And it's again, yeah. And it's again along the lines of we have 3 columns here and 4 rows. So that means I need to compare 2 columns with at least 3 of the rows, because the 4th one's going to come from it anyways. They all add up. Okay? All right? Yes? And you would say, since they're all within 2% of each other, we have evidence. And please, again, do not say prove. Do not say something absolutely is true. You say that it appears. We think they're independent. Because remember, this is based off of our sample. And where you live or where your sample or how you sampled, that actually might not be the case. So in this class, period, never say something is true. It appears to be, or your evidence supports the claim that. Okay? All right. So we did that, we did that, we did that. Boom! Nope, that's not what I wanted to do. Okay, that just totally ruined it. There we go. Clear your desks. A couple of years ago, that was actually more funny. Winter is coming. Yes, I was a massive fan of Game of Thrones. And now I cannot wait for, what is it, Mortal Elements or Mortal Beasts or the next HBO thing. Looks really cool. It's got like Jude Law in it, and I'm still recording. Pause! Running a little bit low on time here, but that's okay because we can still kind of like beat our way through this. So this third chapter is about displaying and describing quantitative data. So we're doing a little bit of a shift here. And whenever we do these things, you always want to think, show, tell. Everything in statistics is set up to be think, show, tell. That means you have to think about what kind of a situation you have, show your work for it, and then explain it to somebody. When we're describing a distribution for quantitative data, no matter what, you have to describe shape, center, and spread. That's absolutely crucial. Anytime you hear the words describe the distribution, that means shape, center, spread. So if we're looking at this, what is the general shape of this graph? Skewed left. This one is skewed right, where that is symmetric. And we basically call all of these unimodal. And then you've got skewed, skewed, and symmetric. Now, the question is, what do you use to describe center and spread? If you have data that's skewed, so this green and the blue one, if you have skewed data, you must always represent the median and their interquartile range. Always both of those talking about being ranged from smallest to largest. Whereas if your shape is symmetric, we're going to be talking about mean and standard deviation. So if you have a graph that looks like this green one and I ask you to describe shape, center, spread, you would tell me skewed left, the median is, the interquartile range is. Whereas for this reddish one, you're going to say the shape is unimodal and symmetric, so the mean and standard deviation are, and then you would provide those. So the median is where exactly half of your data falls at or below that value. So what you're going to do for median and for any of these quartiles, you're going to take median as half, so that's 0.5. 0.5 times your total group size, and you're going to look at that value. If it ends up being a 0.5, you're going to go, this is the only time you do, you take those two values, and you find the average of those two values. Okay? So, that's what I just said. It always has the same units. Center is going to maintain the same units as the original data. And if I look at this, I would say, okay, this data is slightly skewed to the left, which is why I'm giving you the median as about 7.0. 50% of my bars, if I were to weigh these bars themselves, I've got 50% on the left, 50% on the right. And when we're talking about spread and variation are the words that we're going to be using interchangeably. Variation is how much does it change, so that's how much is the data spread out. So we're going to be looking at this as saying how tightly clustered around whatever we're talking about the center being are we? So the range, y'all know, right? Range is biggest minus smallest. We're clear on that? We're not going to use range very often because if you have one single outlier, like if I'm talking about the income of everybody in Haymarket, and let's for some reason say Elon Musk was visiting, that would completely make that range ridiculous. So we don't really deal with range all that often, which is why we typically deal with standard deviations in the interquartile range. The interquartile range is good with skewed data because it says I'm not going to be dealing with the top 25% or the bottom 25%. I'm just looking at that middle 50%. And our quartiles, what is a quarter? A currency, 25% or 1/4. So it's going to divide all of your data into 4 equal sections. And by equal, we're not saying the measurement length. We're talking about how many things are in each of those. So you're going to take 0.25 times for your quartile 1, 0.75 for quartile 2. And for that, what we're looking at is we're looking at the nearest number at or below that position. Okay? At or below is the way AP explains quartiles. The difference between those two quartiles is your interquartile range. So you figure out what your quarter 1 guy is, and that should be quarter 3. And your quarter 3 is, and then you subtract the difference. There's your IQR, your interquartile range. So when I say IQR, know that that's what we're talking about, because IQR is going to be really, really big. So we've got the 25th and 75th percentile of the data. So that means between 25 and 75% is 50%. So we're going to say here is 7 was my median. 25% of the data goes out this way. 25% goes out that way. Your interquartile range is this piece here minus this piece here, so it's 0.9. Pretty straightforward. You guys heard of interquartile ranges before? Some of you know? Okay. All right, so I am not sure if we're probably not going to have time to get through this one. So we're not going to have time to get through this question here, but next class, we're going to start the class with this, because it's important that I get to show you how to graph this, not just by hand, but on your calculator. So what I'd like you guys to do, please listen. On your own paper, I want you to make a dot plot of this data, and then describe it. Describe shape, center, and spread. Okay? And what we're going to do is on Wednesday, we're going to come back, we're going to put this into our calculator, and I'll show you how to get it to work on your calculator. Okay? Okay, we are going to be spending 2 days on Chapter 3. There is a video for you guys, and the video is all about how to make box and whisker plots. We just are not going to have time to sit down in class where I tell you step 1, step 2, step 3, step 4. Again, it's a 10-minute video. Take your notes. Okay? Thank you, ladies and gentlemen.